Hi, this is Kevin Trainer. Welcome to part 3 of my lecture on chapter 5 of the Zelle Python text 3rd edition. And in this part, we're going to be talking about files and file processing. And I'm going to get back to the slides in a minute, but I just want to make sure that we all know what we're talking about when we're talking about files. And we're talking about, in this case, text files. So we're all pretty used to text files. What I have open here on my desktop is a text editor called TextMate that runs on the Mac, and it's a pretty good text editor. But let's see. Let's put some text in. So I'll type in the quick brown fox jumped over the lazy dog. Okay, and I can make the text a little bigger. You can usually zoom in. All right, so I did that. So right now I just have a bunch of text. I have a single line of text. Have I ended the line? No, I haven't ended the line. How can I tell? Well, because in your average text editor, when you end a line, you see the beginning of the next. So if I hit the return key on my keyboard, you'll see that I've ended the first line and started the second. Okay? I haven't typed anything on the second. Okay? And this is how text files show up in a typical text editor. And what is interesting is that earlier in the chapter we learned about the new line character. Now, different computers use different combinations of characters to signal the end of a line. And one is the line feed character. Another one is a carriage return character. And it used to be that the Mac would use one combination, Windows would use another combination, but the general kind of generally accepted overall combination is to just use a line feed character, and that's what we mean when we say a new line. So when we in Python, when we print a line of text and then we go on to the next line, sort of invisible at the end of it is a new line. And we learned how we could put that explicitly in a character string by putting \n. Okay, so when we do a print and then we go on to the next print, well, what comes out at the end of the line is a new line character. Okay, now when you take a text file like this and you display it in a text editor, well, it eats up all the new line characters and it puts the next text on a new line. It pays attention to the command. So now we might say on the next line, how now brown cow. And return to new line. And now is the time for all good women to come to the aid of their country. Okay? Now, if this is the end of the file, do I have to have a new line here? Nope. If you look at a lot of text files, it's typical for people to put a new line at the end. So a lot of text files look like this. So the last line is empty. Well, that really means that there isn't a last line there. Okay, what we have is a line before ends in a new line. Okay, and the way that it gets displayed in a text editor is to get you ready to start a new line. Okay, so that's what the lines are. They don't have to be the same length. They don't have to have the same amount of data on them. And lines are ended by a new line character in the kind of encoding that we're using with our files. And if you want to save these lines, well, you can say file, I want to save as, and let's put it into downloads because I've got a lot of things there. And we'll just call this lecture example 1. We can save it. All right. And now that we have saved this file in the operating system, well, we can go out and open it up. So we can go to downloads and we can look for, probably want this to be in date added order. Lecture example 1 is up at the top. Okay. So we're going to open that up. And this opened in another text editor. But what's interesting is that it's sort of a standard way to create text files. Let's open it up with the same editor that I had before. We'll say open with TextMate. And there it is. It looks like it did before. Okay, and we can open up really any kind of text any kind of text file with any kind of text editor. I had another file here. This could be this one here. Let me see if this is it or not. Open with TextMate. Yeah, and here's Herman Melville's Moby Dick. And I got this from a website from this www.gutenberg.org. It's Project Gutenberg, and it has kind of in the public domain books and documents. And in this case, we just have Moby Dick, the novel, as a text document. And it just goes on and on and on, right? Well, what's interesting is we may only have the what we may really have is a document. We have a file that is a kind of a README file for Moby Dick. So we would have to go down and the complete text, I guess we'd have to click on this link here. But this is a longer text document. And the files that we're going to learn about, you can put text in them, you can put numbers in them, you can put whatever you want. But this is when we're talking about processing files, we're talking about plain old text documents you can open up with a text editor. And you can be using one that you created or somebody else created, or you can create one with the program, and if you want to see what's in it, you can just go to that directory and open it up with a text editor like TextMate, and then you can see it. And to the extent that there appears to be more than one line, it's those line breaks are created with the new line character, which of course when we code it into a character string in Python is the \lowercase n. Okay, that's what we mean by files. So let's go back to the slides. So if we're going to process a file, the process of opening a file, let me back up. So I already told you that the work that we do at the console, when we do an input or when we do a print, that those are really files, that the inputs are coming from the input console file and the prints are going to the output console file. And they're really text files, okay? And they're really kind of hardwired, connected up with the command line, with the console, okay? And do we have to do things like opening and closing the console file? No, it's made pretty easy for us by the Python infrastructure, such that we can do inputs from the console without having to go through all the formalities we're going to see here for how to read from a file. And we can do outputs to the console with print without having to go through the formalities that we have here. It's just kind of a learner's crutch. Okay, so now when we're going to be talking about file processing, we're going to be learning enough to be able to do text files that are on our hard drive or somewhere else that we have access to. Okay, so when we're going to deal with normal file, not the special kind of console-related files, we typically have to open them before we begin to process them, either for reading or for writing. So the process of opening a file involves associating a file on a disk with an object in the memory of our program. We can manipulate the file by manipulating this object. So we'll have a variable name that represents the file in our program. Okay, and we can refer to the file by that variable name. And then we can do operations on it. We can read from the file. We can write to the file. When we're done with the file, it needs to be closed. Closing the file causes any outstanding operations and other bookkeeping for the file to be completed. Well, what do we mean by that? Oh, and one more. In some cases, not properly closing an output file, it doesn't say an output file, but that's what it means, could result in data loss. Okay, and most of us understand that our programs are running under an operating system. In my case, Mac OS, and in your case, it could be that or Windows. And what happens is while a program is writing out a file, it cooperates with the operating system in getting the lines written out to the disk file. And when we close the file, it's our opportunity to tell Python to tell the operating system, okay, we're done. Make sure all the records are out there and nicely bundled, and this is ready to be stored. So if you run a program in Python and you don't close the output file, you might not see the last couple of things that the last couple of lines that you wrote actually out on the disk, because you didn't do the kind of tidying up at the end of the program that you needed to do by closing the file. Okay? When you're reading an input file, it would be hard to lose data this way. We close input files because it's a polite thing to do. So, of course, we just looked at a text editor, and of course, a text editor is a kind of limited functionality word processor. So, if we're using that kind of application program, well, when we want to work with a text document, we open the file. It reads the contents of the file into the memory of the computer, the random access of memory. It closes the file, okay, and then we make changes in the in-memory copy. Okay, we don't make changes on the disk. It may look like we are. Okay, and then usually when we're done, we have to save it back. We do a save or a save as. And what happens then? Well, it's writing the contents of the document that are in our memory. It's writing it out to the file, and if we don't say a new file name, it writes it right over top of the old file. Okay? So file writing operations copy the version of the document in the memory to the disk, and then the file is closed. Okay, so when we were just processing the documents with a word processor, when we opened the file, there was an open, and then a closed, actually. And then we're in the memory, we're editing. So when it begins, it opens it for reading, it copies in all the text, it closes it, and we change it. And then we say we want to save it, then it opens it for writing, and it writes over top of the original file or some other file if we say a save as. And then it closes it in the end to flush out the last couple of lines of data out of the memory of the computer and onto the hard drive. Okay, so what's interesting is just using a text editor or a word processing program, we have a kind of implicit idea of opening and closing files and reading and writing the contents. And now we're just going to do some of that ourselves under Python control. Okay, so how do we open a file in Python? Well, we have a variable name that holds a reference to the file, and we assign it the result of doing an open. So we say open, and we have a file name, and the second argument is a mode. So in the example down at the bottom, the variable name is infile, so that's a hint that this is going to be an input file. And we open, and then we give it a character string, numbers.date, okay, D-A-T, probably data, and then comma R. We want to open it for reading. So this is an input file. Okay. And then once we have an input file open, there are several methods we can call on the file object. We can do a read, we can do a read line, we can do a read lines. Well, what do these do? Well, I'm going to give you a hint. They deal with the fact that the text file is another kind of a sequence. Okay, and it's not really hard to think of it. You could think of the text file that we looked at before. You could think of it as one long sequence of characters, right? Or you could think of it as a sequence of lines, right? You know, it turns out that we can conceive of it in either of those ways when we're issuing the read commands to the file. So if we just use the variable that holds the reference to the file and we call read on it, it returns the entire remaining contents of the file as a single, possibly large, multi-line string. Well, that's interesting. Now, why does that work so easily? Well, when you think of it, a file is a pretty complex sequence, and the string is really the simplest of the sequences that we've learned about. And what happens is that you can take the sequence of characters that are in the file, and you can say, let's treat them as one big string. So it's sort of a really kind of clumsy and gross mapping of sequence to sequence. What about a read line? Well, read line returns the next line of the file. That's all text up to and including the new line character. Okay. Well, that's good. It's really a subsequence. Okay, when you think of a line in a file, well, it's a sequence in its own right, but the lines in a file are a sequence. Okay, and we can think of all the characters as a sequence too. So depending upon the point of view that we want to take, we could have that. So one of the things that people do, especially if they have really long files, millions and millions of lines, well, they read a line at a time, and they do the processing because they don't really want to read the whole file into memory. What would you do if you read it into memory? Well, we're going to see in a minute there's a really easy way to take a file and turn it into a list, okay, of all the lines in the file. Each line in the file becomes an item on the list. This is why it's so important to realize that these sequences between the character string, the list, and the file, they're all related to each other, and here the way that we do the reads gives us a kind of alternate mapping. So if we use read, we get the whole file, and we put it into a variable that becomes one big string. If we do read line, we just get the next line, so all the rest of the lines after that are left, and we just get a modest-sized string. Or we can do this really cool thing. If we have a file that's not too big, okay, that can fit into memory, then we can do read lines, and what happens is each line in the file becomes an item in a list. And then we can close the input file and process the list. Well, why would we want to do that? Well, we could process the list as many times as we wanted. Okay? Well, some kinds of processing requires us to process the data more than once. Well, what kind? Well, if we had numbers, and let's say we wanted to read a number off of every line. So every number is on a new line, right? And that what we eventually wanted to do is we wanted to be able to report the observation and then how far it was from the average, right? Well, what do we have to do to calculate the average? Well, we need to read through the entire file. And then we need to read through the entire file again in order to process each one and print the observation and the difference between that observation and the average. Okay, so I mean that's a very simple thing that requires us really to process all the data twice. And there are quite a few data manipulation things that require you to process the data more than once. So one of the interesting things that people do when they have that kind of need is if there's not too much data, then they turn the external text file into a list of strings, and then they process it till their heart's delight. Okay? So you can get the contents of a text file as one big string, or you can get it one line at a time as a modest-sized string, then another one, then another one, then another one, or you can kind of have the compromise. You can tell it to consider the lines as the things that you're interested in, and just to create a list that contains each item in the list as one of the lines in the file. So this is a really classy mapping between these different kinds of sequences. It's really beautiful. Okay, so what kind of things could we do that rely on that? Well, in this first case, we're just going to print a file to the screen. So we say fname, that's a file name, equals input the file name. And then we create the variable in file, and we give it the reference that comes from opening fname. So this is a character string that is going to have the file name and extension for reading. We can say data in file read. Okay, so it's a read. It's going to get the entire contents of the file and plunk it into the variable called data, and then we're going to print data. Okay, and what happens? Well, the entire contents of the file are going to come out on the console. Is it going to come out as one long line? Well, it depends on whether there were lines in the initial file. If there were new lines in it, like there is in a typical text file, well, it's going to come out on a lot of different lines. Okay? So this is a pretty simple way to do this in just one big read, one big write. Okay? And so you can think of a text file as one giant sequence of characters, and you can handle it that way both on the input side and on the output side. Okay? Hang on. We'll get there. There we are. Okay. Read line can be used to read the next line from a file, including the trailing new line character. Okay, so what are we going to do? So we can say, here's an alternative. So we can open an input file for reading, and we're calling it in file again. And now we're going to say for I in range 5. Okay, so that means we're going to get a sequence of 5 integers from 0 to 4. Okay, we're not using I within the body of the loops. It doesn't really matter that they go from 0 to 4. We're going to go around 5 times. So we say line, that's a variable name, is going to get in file read line. That's a line at a time. So we're going to plunk the first line here, and then we're going to print the line. Now this is an interesting thing. Remember the slices. Okay, so this is a slice that has no entry, :-1. So this says, I want you to print the whole line except the last character. Well, why is that? Well, because the last character is a new line. When you read these things in, you really see the new lines. They're really there. Okay? And when we print, it adds a new line under the end. So if in fact we didn't have this expression at the end to get the slice that leaves out the new line, we would print these double spaced. Well, we don't want that. They didn't come in double spaced. Okay? So this reads the first 5 lines of a file. Slicing is used to strip out the new line characters at the ends of the lines. We have to strip them out because we're adding them on with the print. Okay, so these kind of cancel each other out. So we get single line spacing. Good. Another way to loop through the contents of a file is to read it with the read lines and then to loop through the resulting list. Okay, so we could do this. So we could open some file to read. The reference is going to be in the variable in file. And we can say for line in file read lines, have the line processing here, and then we could close the input file. So one of the really cool things about Python looking at the string, the list, and the file as all sequences is you can use for in with all 3. You can use for in to iterate over the characters in a string. You can use for in to iterate over the items in a list. And you can use for in to iterate over the lines in a text file. And then you get them one at a time. Now what's nice here is that you get the benefit of that without having to decide that you want to read the file into a list and then you're going to iterate over the list. Okay, you could do that, but you'd have to be able to fit all of the file into memory at one time. In this case, we're not iterating over a list. We're actually iterating over the lines of a file. So this is a way to read a file with a for loop and get a line at a time. So the body that we go here would be the code to process a line at a time. If we're only printing the file, well, then we would need to do the same thing we did in the in the last version. We would have to print, and we'd have to use a slice that took off the last character, which had the new line, or else we would get double spacing. Sorry, not getting to somehow I'm going to get to my next slide. Here we go. So in this case, Python's treating the file itself as a sequence of lines. Isn't that beautiful? I mean, I'm sounding really geeky now, and I apologize for that. But it's only because all three of these things, the string, the list, and the file, are all sequences that you can process them with the same construct, the for in construct. It's beautiful. Okay, so let's go through some more of the practicalities of reading and writing files. Okay, again, we've really been reading and writing files since the beginning. Okay, when we get a line of input from the console, that's really a read from the console file, and when we print a line of text to the console, we're really printing to the console output file. Okay, it's just the Python infrastructure has hidden all that from us, so that we didn't have to know so much to get this far in the course. Okay, so we've been reading and writing files all along. Now we're just doing it more formally. So file processing, opening a file for writing prepares the file to receive data. Okay, now we can open a file that already exists, in which case we're going to overwrite it. Where we can open a file name that doesn't exist, in which case it'll be created for us. Okay. So we here we decided to call this the variable out file. It gets a reference to the file if we do an open mydata.out with a W for write. Okay. Now, how do we print to something other than the console? Well, it's pretty easy, because we say print, and then in parens we have the normal expressions that we use to get the stuff out there, and then we just say file equals out file, and it goes to the out file instead of to the console. Pretty slick, huh? Okay. Let's see more examples of this. Okay, so we will, but not before we talk about batch mode. Okay, so what's batch mode? Well, batch mode is kind of an older style of processing compared to online mode. Okay, so in online mode, which is your typical web application, you give the data to the computer one transaction at a time. Okay, so typically you type a transaction into some kind of a web form. You click on a button. That request from the browser gets sent into some kind of web application server. It takes that as input. It acts on it. Maybe it stores something in the database. Maybe it changes something in the database. Maybe it deletes something in the database. It does some kind of action on its data store, and then it sends you a response back. And then that's kind of over. So typical online transactions that we have are single transaction, one action per, one input, one action, one response. Okay. Now, in the early days of computing, we didn't have all these online capabilities, and so what we did is we took the things we wanted to do, and we put each of the transactions into typically a line of a text file. Okay, and we batched them all together. So instead of a single transaction, it was a batch of transactions. How did we know what was in the batch? Well, how many lines were in the text file? Okay. So if you write a batch processing program, instead of just doing something once, it typically does it once for every line of input. And a lot of these things create a line of output for every line of input. Okay? So this mode, it's kind of interesting because it's like taking some of the design that we were using in earlier chapters where we would ask the user for one input and then we would process it and create one output. It's kind of like putting that in a loop, right? And we certainly can do that even with a user being prompted in kind of an online mode for a series of inputs. But if we have a lot of data and we want to compute a lot of answers, it's pretty typical for us to take a page out of the old world data processing and do a batch style program. So what could we do like this? Well, remember the usernames that we created earlier in the chapter? Well, let's say that we had a list of first names and last names. Couldn't we process those in a loop one at a time and turn out a list of usernames in the output file? Well, in fact, we can, and that's what we're going to do. If we can get to the next slide. Here we are. So let's look at this. It's the same thing. Our code's in the main. So we print out this program creates a file of usernames from a file of names, as in first name, last name. So we prompt the user and get a file name for the input file, a file name for the output file, and then, file name for the input file, a file name for the output file. What do we do here? Well, this is interesting because I guess this is Python. There's a lot of comments in it. And a lot of these comments, again, are pretty operational for comments for me. Again, comments that we want to leave in our code and we're not in some kind of teaching mode. We want to cut down on the play-by-play. We want to write our code. I had a really interesting conversation with Julie tonight, the TA for this semester, and we were talking about how we didn't want comments to give us a lot of the play-by-play, and she suggested that this idea is that let the variable names do the talking. Okay, so you can usually in code, if you pick good variable names, and people can kind of understand what code does, you can usually put some kind of intentional comment at the top, and people can get the story of the code by reading the code itself. So, so we say for line in file. Okay, so this is for line in file. So, so at this point, line holds a line of text. Okay, we split a line. Do we say to split it on a certain character? No, it's going to split on the space. Okay, so we're expecting first name space last name. Okay, and then we do a double assignment. So we're going to put the first name into first and the last name into last. And then we say create a username. Okay, so this is the same code that we had before. and we say write it to the output file, and we use a print. Okay, we just print like we normally do. We just have to remember to add on file equals out file. Now we close both of the files. Okay, in terms of closing the in file, it's good coding practice. There are will it cause the world to end if you don't close your in file? No, it doesn't. But in large programming environments where we have we're sharing programs between a number of transactions and such, leaving files open creates what we call a memory leak. So it creates these programming objects that kind of hang around and don't go away. So the program memory space just gets bigger and bigger and bigger. So in-file close in a short program like we have here is more politeness than anything else. But in a large multi-processing system, it might have some more we might have some practical problems if we didn't close input files. And the out file close, well, it would be the same issue with not stranding resources in our program in a more multi-user, multi-programming environment. But also, we need to force the last couple of lines out of the memory of the computer and onto the hard drive. Okay, so that was pretty easy to do. One of the reasons that this is so easy to write is because Python allows us to process a text file as a sequence. Because we can just say for line and in file, it's just a loop. It's beautiful. Okay? And then they printed something to the console. I mean, here we say usernames have been written to, comma, so we're going to get a space, out file name. Okay, this is good. It's a good thing when you're writing programs that read disk files and write to disk files. They have a way you say you want to run them, and they just sit there silent. So one of the nice things is to be able to say this as a way of saying, I'm done. I did what you asked me to do. Things to note. It's not unusual for programs to have multiple files open for reading and writing at the same time. Okay, that's true. And in fact, the nature of a batch application, like we just saw, is typically we're taking one or more input files representing transactions, and we are looping over them, and we're creating one or more output files. The easiest case, the one that's easiest to understand, is the one we have at hand. One input file, each line is a transaction, and one output file, each line is a result of that transaction. The lower method is used to convert the names to all lowercase. I think we talked about that when we did the single version of this. You can really take any program that we've done so far that we had, we just did one iteration, we just did something once. You can redesign that to do a batch mode, read lines of input from the input file, do whatever work we learned how to do, and then write lines of output to the output file. So it's pretty easy to take a program like we had that created the username for one user, and to sort of redesign it to read a whole series of inputs and to create a whole series of outputs. Okay, now this is something that they've added in the new version of the book, and I really like it because most of us are not used to programs that ask us to type in the file name. Okay, most of us are used to more graphical interaction with programs, And so what they've done is that they've given us we're using some of the Python modules to get more functionality. Okay, and what we really would like to do is to go searching for the file that we want in the proper directory that we want. Okay, we have this concept of the current directory. So the files that we read and write by default have to be in the same directory as the Python program. Well, that's not so big of a problem if we just include them in our project. Okay, so we've got Python files in our project. We've got text files in our project. That's fine. But what if we wanted to keep the text files somewhere else? Well, there are expressions where we can say exactly what the path is to that file in the file system, but they can get kind of hairy. And so one of the things that we've decided to do is tell you is to have you search for the file or the place to put the file graphically. Okay. There's also the problem between Windows and Mac that if you're trying to have if you're trying to come up with a full file path expression that ends with the file name, that on Windows the slashes go backwards, and on the Mac the slashes between the directories go forward. So that can be kind of problematic. So what we've decided to do is to show you enough code so that you can have a pretty solution to this. And it won't work. Let me try to get to 104. Here we are. So here's a case where on Windows the slashes are going forward, and a full path expression on the Mac the slashes would go backwards. So it can be kind of challenging to get the right expression to point to the file that you want. There is a method from the package called tkinter file dialog. So we're going to have to import that. Okay, so we say from tkinter file dialog import ask open file name. Okay, so we do an import so we could use it. And instead of going through a dialogue with the user where we prompt for the file name, we just do a function call, and what we get back is a reference to the file that they picked. So this is a file picker function. Okay, and of course I'm sorry, what we did get back is the file name that we picked. Okay, well, complete with the path and everything else that we need. Okay, so then we can just use this file name, which is what we get from ask open file name, not ask open file name. So then in the next line, we just open that name. Okay, and here's what it looks like. It's the kind of graphical dialogue that you're used to, where you're able to go from directory to directory and find just the file and click on open. And there you are. Okay. So when the user clicks the open button, the complete path name of the file is returned as a string and saved into the variable in file name. If the user clicks cancel, the function returns an empty string. So it was possible before for the user to type in just a carriage return and send us back an empty string. And we will learn about how to catch error situations and recover from them. But right now, we just, if the user hits us on the chin, we simply take one on the chin. Okay. To ask the user for the name of a file to save, we can use ask save as file name. So here's how we import that from tkinter file dialog, import ask save as file name. So we just say out file equal ask save as file name. Okay, and then we're able to open that for write. And then how do we do that? Well, it's the same thing. Instead of open, the button's going to say save. And if you cancel, it sends back an empty string. And as of right now, we're trusting the user to not do bad things. But we certainly will learn how to write the code to recover from that situation. So it's a long chapter. Again, I apologize for it being long, but the beauty of it is that this is more than any chapter of its sort that I've seen. This does the best job of explaining the similarities between character strings, lists, and files. They're all sequences of something. And in fact, this gives us some real power when it comes to file processing. The nicest thing we can do here, if we can go back to find the code, is our ability to do just this. Our ability to create a loop that reads one line of a text file at a time, and we can just say for line in file, and it couldn't be more beautiful. Okay. Now I just want to point out that we said in file close here. We're going to expect you to close every file that you open. So if in fact that's true. We only had in file, and we're probably printing. But in one of the versions, the batch version, we showed that we open both an input and an output file, and I'm going to expect you to close both the input and the output file. Well, that's enough lecture. Thanks for hanging in there. I'm going to say bye until next chapter. Bye-bye.